So, dear students, we are learning about conic sections or conics. We have learned that there are three types of conics depending upon the value of the eccentricity. If the value of eccentricity is 1, the conic is a parabola. If the value of eccentricity less than 1, the conic is an ellipse. If the value of eccentricity greater than 1, then the conic is a hyperbola. That we have learned. Okay. We have already learned about parabola, and today we are going to learn about ellipse. Okay. So, what is an ellipse? When the eccentricity becomes less than 1, the conic becomes an ellipse. Now, what is the shape of an ellipse? This is the shape of an ellipse, oval like. Okay, this is the shape of an ellipse. Okay, so ellipse is a closed curve. Okay, so this is a closed curve. Unlike the parabola, parabola is an open curve, while ellipse is a closed curve. Now, we know the line of symmetry of a conic is called its axis. So, this ellipse, in this ellipse there are two lines of symmetry. Of course, there are infinite numbers of lines of symmetry, but this is the longest line of symmetry and this is the shortest line of symmetry. This longest line of symmetry is called the major axis and this shortest line of symmetry is called the minor axis. So, the longest one is the major axis and the shortest is the minor axis. So, these two axes are important, major axis and minor axis. Okay. So, what is axis? Do you remember? The line of symmetry is an axis, and in case of ellipse, this longest line of symmetry is called the major axis and the shortest line of symmetry is called the minor axis. Now, let us find the vertices of the ellipse. What is a vertex? Vertex is the point at which the axis cuts the conic. So, where does the axis cuts the conic? At these 2 points. So, these two are vertices and these two are also vertices where the minor axis cuts the ellipse. But these are not called vertices, rather these are called co-vertices. So, these 2 points B1 and B2 are called the co-vertices and these 2 points A1 and A2 are called the vertices. Now, do you remember center? Ellipse is a central conic, whereas parabola is a non-central conic. So, what is the definition of center? Center is the point at which the line of symmetry intersects, or the point through which all the line of symmetry passes. You see, through these points all the line of symmetry will pass. So, this point O is called the center of the ellipse. Okay. Next, these 2 points F1 and F2, F1 and F2, F2 is here. F1 and F2 are called the foci of the ellipse. Okay. Now, eccentricity of ellipse is less than 1, and what is eccentricity? Ratio of the distance of a point on the conic to its distance, that is the distance of the point from a fixed line called directrix, is called the eccentricity of the ellipse. So, in case of ellipse, this suppose generally focus is denoted by S, but as ellipse has 2 foci, so we have denoted these 2 foci as F1 and F2. In some books you can find it as S1, S2. Symbols does not matter, what matters is the meaning. Okay. So, these are the foci. If we consider F2 as S for definition as S, then PS by PM less than 1, this implies PS is less than PM. Thus, for any point on the ellipse, if we take anywhere the point here, 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 on this part we will refer this as focus and this as directrix. For this part we will refer this as focus and this as directrix. Okay. So, for any position of the point on the ellipse, the ratio of its distance from the focus to its distance from the directrix should be less than 1, or in other words PS should be less than PM. Okay. Now, you see these things, XO, X dash, that is X axis is taken as the major axis, YO, Y dash, Y axis is taken as the minor axis. A1 and A2 are the vertices, B1 and B2 are the co-vertices. A1, A2, the distance between the points A1, A2, that means this length A1, A2 is called length of the major axis. This length A1, A2 is called the length of the major axis, and this is generally taken as twice A. B1, B2, that means distance between the points B1, B2, this length B1, B2 is called the length of the minor axis. This is generally taken as twice B. So B1, B2 is equal to twice B is the length of the minor axis. F1 and F2 are the foci. Distance between F1 and F2 is taken as twice C. So twice C is the distance between the two foci. This length F1, F2 is twice C, and this is the distance between the two foci. Then D1, R1 and D2, R2. D1, R1 and D2, R2 are the two directrices of the ellipse. So an ellipse has two directrices and two foci. Okay, foci is the plural of focus and directrices is the plural of directrix. Okay, so has two directrices. Now the distance between directrices D1, R1 and D2, R2 is Z1, Z2, and this length Z1, Z2 is equal to twice A by E. Equation of the ellipse is x square by a square plus y square by b square is equal to 1, where b square is equal to s square minus c square and c is equal to ae. Okay. So equation of the ellipse is x square by a square plus y square by b square is equal to 1, and there is a relation between s square and b square. What is that relation? This is very important relation. B square is equal to s square minus c square. What is c here? Value of c is ae. A means this a, where twice A is the length of major axis and E is the eccentricity of the ellipse. What is A? A is half the length of major axis. And what is E? E is the eccentricity of the ellipse. Okay. Now, depending on value of C, ellipse will take different shapes. C means A is a constant, and what varies is E. So depending upon the value of E, which is less than 1, that means E will lie between 0 to 1. Depending upon the eccentricity of ellipse lies between 0 and 1. Okay, lies between 0 and 1, and depending on this value of E, ellipse will take different shape. As we have C here, so we can say that C depends upon E. So we may say that depending upon the value of C, ellipse takes different shapes. How? As E varies from 0 to E, so C must vary from 0 to A. C will vary from 0 to A. When E varies from 0 to 1, C will vary from 0 to A, because C is equal to AE. Now, what shape does it take? When C is equal to 0, when C becomes 0. You may observe from this relation, when C becomes 0, b square will be equal to s square. B square becomes s square. Now, in the equation of ellipse, we consider b square equal to s square. That means, if we write s square in place of b square, the equation will take this structure, this shape, and which on simplification becomes x square plus y square is equal to s square. What is this? X square plus y square is equal to s square. Which curve does it represent? If you can remember, this is the equation of a circle with center at origin. This is the equation of a circle with center at origin. Okay, what is the equation of circle? Standard equation of circle is x minus h whole square plus y minus k whole square is equal to r square. Okay, if h and k become 0 and r is equal to a, then this equation takes the form x square plus y square is equal to s square, which is the equation of a circle. So we can say that when C becomes 0, when C becomes 0, E becomes 0. So when the eccentricity is 0, the ellipse takes the circular shape. So ellipse becomes a circle. The circle is a special case of ellipse. So when an ellipse becomes a circle, an ellipse becomes a circle when its eccentricity is 0 or C is equal to 0. Okay. So the least value of E eccentricity is 0 and the least value of C is also 0. So when eccentricity is the least, the ellipse becomes a circle. Now eccentricity goes on increasing from 0 to 1, and according Accordingly, C also goes on increasing from 0 to A. Okay. So when C is 0, the ellipse is a circle, and when the value of C or the value of E increases, the ellipse stretches. Okay, stretches. The highest value that C can take is A, as the highest value that E can take is 1. So when E becomes 1, C becomes A, and in that case the ellipse will flatten and will take the shape of a straight line. When C becomes equal to A, the ellipse will flatten and it will become a straight line, the straight line joining the two foci. Okay, and that straight line will be a straight line joining the two foci. Thus we can say that as value of C increases from 0 to A, the ellipse flattens from circle to a straight line. Okay, so these are some things that you have to remember. These are the things you have to remember. Now we will discuss about standard equation of ellipse. Now we are going to discuss about an important property of ellipse. So before discussing that important property, let me tell you how can you draw an ellipse. You take a thread like this. Okay. You fasten this thread to two nails on a wooden plane. Okay, you fix two nails, okay, and then fix the two ends of the thread to the nails. Then you fasten a pencil here, okay, just like this, so that the pencil can move. All right, just like this, so that the pencil can move. Fasten like this, so that the pencil can roll. All right. You fix two ends of the thread to the two nails, then you fasten a pencil here and move the pencil on the board so that the thread remains stretched. Okay, then you move the pencil. The pencil will draw an ellipse. This is the way for drawing an ellipse. All right. Now let us try to understand this length of the thread and these two nails. Okay, the length of the thread should be equal to the length of the major axis of the ellipse. The length of the thread becomes the length of the major axis of the ellipse, and these two nails becomes the two foci of the ellipse. Okay, so you have fixed two ends here, and this is the point P where your pencil is the point P, is the moving point on the ellipse. All right, your pencil becomes the moving point on the ellipse. So what is the property? Sum of the distances of any point on the ellipse from the two foci is constant, equal to the length of the thread. And what is the length of the thread? Length of the thread is the length of major axis of the ellipse. So thus the property becomes sum of the distances of any point on an ellipse from the two foci is always a constant, and that constant is equal to the length of the major axis of the ellipse. So this is an important property of ellipse. We use this property to draw an ellipse. Now we will use this property to find the standard equation of ellipse. Now to find the standard equation of ellipse, let f1, f2 be the foci. That means f1, f2 are any 2 points on the plane, and we have taken these 2 points f1, f2 as the foci. And O be the midpoint of f1, f2. O is the midpoint of f1, f2. Let f1, f2 is equal to twice c. We have taken this length f1, f2 as twice c, so that f1, f2 is twice c. So OF1 and OF2 both must be equal to c, because f1, f2 is equal to twice c. Okay. Let O be the origin. We have chosen O as the origin. and OF2 stressed is the positive x-axis, OF1 stressed in the side is the negative x-axis. OF1 be the negative x-axis and OF2 be the positive x-axis. Let the line YOY dash perpendicular to F1 F2, YOY dash perpendicular to F1 F2 and passing through O be the y-axis. So with this choice of coordinates, the coordinates of F1 and F2 are minus C0 and C0 respectively. So we have written therefore coordinates of F1 and F2 are minus C0 and C0 respectively. Let Pxy be any point on the ellipse. Pxy coordinates Pxy be any point on the ellipse. Therefore, by definition of ellipse, definition means that property of ellipse, that what is the property? Sum of the distances of any point on an ellipse from the two foci is a constant. So we have taken P any point on the ellipse and sum of its distances, that is Pf1 plus Pf2 is equal to constant, and that constant is taken here as twice A. Okay. Now let us simplify this. Pf1 plus Pf2 is equal to twice A. What is Pf1? Pf1 is the distance between P and F1. So using distance formula we can find Pf1. So from this will imply under root, by using distance formula, x minus c, that is x plus c whole square plus y minus 0 whole square. This is our Pf1 plus Pf2 distance between P and F2. Coordinates of P are xy and coordinates of F2 are c0. So this will be x minus c whole square plus y minus 0 whole square under root is equal to twice A. Now let us simplify this. This implies under root x plus c whole square plus y minus 0, that means y square, is equal to twice A, this part is brought to that side, minus root over x minus c whole square plus y square. Now we will square both sides. Squaring both sides, on squaring the square root will go off. So we will get x plus c whole square plus y square. So this is a minus b whole square. So a square plus b square minus twice a means twice a, into b means this part. Okay. So on squaring we get this quantity. Now y square, these two will be cancelled. On simplifying, x plus c whole square, this x minus c is brought to left hand side, minus x minus c whole square is equal to twice a whole square, 4s square, twice a whole square is 4s square, minus 4a into under root x minus c whole square plus y square. Now a plus b whole square minus a minus b whole square is equal to 4ab. So x plus c whole square minus x minus c whole square will be 4cx. So this will become 4cx equal to 4a square minus 4a into under root x minus c whole square plus y square. 4 will be cancelled and we will be left with cx is equal to s square minus a into under root x minus c whole square plus y square. Again on simplifying, we bring this quantity on the left hand side, so it will become positive and will be a into x minus c whole square plus y square. So this will be equal to s square minus cx. Again squaring both sides. So on squaring, this will become s square into x minus c whole square plus y square is equal to square of this will be a to the power 4 plus c square x square minus twice s square cx. Okay. Now expanding this quantity, we will get s square into x minus c whole square, x square plus c square minus twice cx plus y square is equal to a to the power 4 plus c square x square minus 2s square cx. Okay. Applying distributive property, s square x square plus s square c square minus twice s square cx plus y square is equal to a to the power 4 plus c square x square minus 2s square cx. So 2s minus 2s square cx minus 2s square cx will be cancelled. Okay. Then we will be left with s square x square plus s square c square plus y square is equal to a to the power 4 plus c square x square. This s square x square is brought to that side, and taking x square common from these two, it will be x square into s square minus c square plus y square, and this s square c square is brought to that side, is equal to a to the power 4 minus s square c square. Okay. This implies x square into s square minus c square plus y square is equal to s square into s square minus c square. This implies x square b square plus y square is equal to s square b square. What is b square here? Where we have taken this quantity s square minus c square as b square. We have put b square is equal to s square minus c square in this equation. Then dividing both sides with s square into b square, this will be x square by s square, b square cancel, plus okay. So this will be y square s square, 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 y square s square. So dividing by s square b square, this will be y square by b square is equal to 1. This is the standard equation of ellipse where b square is equal to s square minus c square. Okay. And what is this c here? The value of c is equal to AE. The value of c is equal to AE. Thus, the coordinates of foci are minus AE0 and AE0. Now, from the standard equation of ellipse, x square by s square plus y square by b square is equal to 1, we can find some properties of ellipse. First one is there are x square and y square are present. So, since the presence of x square signifies that the curve is symmetrical about y axis. Okay. Why? Because whenever there is some value of x, there will be some negative value of x, because x square is present. It is satisfied by both x and minus x. Okay. Corresponding to any point x here, there will be a minus x here. Okay. So the curve is symmetrical about y axis, and the presence of y square shows the curve is symmetrical about x axis. Corresponding to any y, there will be a minus y. Thus the curve is symmetrical about both the axes. This is the first property. Second property, x square by s square, a square quantity, square of a real number is always non-negative. Y square by b square, a square quantity, this is also non-negative. So x square by s square and y square by b square both are non-negative quantities, and their sum is equal to 1. It means both x square by s square and y square by b square are less than or equal to 1. their maximum value will be 1 and their minimum value will be 0. So we can say that x square by s square is less than or equal to 1. Okay, do you understand this? Both are non-negative quantities and their sum is 1, so both of them must be less than or equal to 1. Less than or equal to 1. This implies x square is less than equal to s square. This implies x square minus s square is less than equal to 0. This implies x plus a into x minus a less than equal to 0. This implies minus a less than equal to x less than equal to a. So for the x coordinate of any point on the parabola, it lies between minus a and plus a. Minimum value of x is minus a and maximum value of x is plus a. Okay. Similarly, we can show that y square by b square less than equal to 1. On simplification, y square minus b square less than equal to 0. So y lies between minus b and plus b. Okay. So the minimum value of y is minus b and the maximum value of y is plus b. So value of y coordinate, that means the ordinate of any point on ellipse, must lie between minus b and plus b. Okay. So these are the two properties. There's something else. Okay. And you see the two foci always lie on the major axis. Two foci always lie on the major axis. Okay. The line joining the foci is the major axis. Okay. Now let us try to find the length of lattice rectum of an ellipse. So what is a lattice rectum? Lattice rectum is a focal chord. Focal chord means the chord passing through the focus. So lattice rectum is a focal chord perpendicular to the axis. So this is a focal chord perpendicular to the axis. So this is one lattice rectum and this is another lattice rectum which is also a focal chord perpendicular to the axis. Thus an ellipse has two lattice rectums. So let us try to find the length of that lattice rectum. Both the lattice rectum are equal in length. Okay. Suppose the end points of the lattice rectum be L1 and L2. Okay. So what will be the coordinate of this L1? Obviously the x coordinate is c. Okay. This length OF1 is c because coordinates of the focus is c0. So this is a line parallel to y axis. So x coordinate of this point is also c. And let the y coordinate be L. We are going to find the value of L. So coordinates of L1 is CL. Now L1 is a point lying on the ellipse x square by s square plus y square by b square is equal to 1. So this must satisfy the equation of the ellipse. This implies, so CL lies on the ellipse, c square by s square plus L square by b square is equal to 1. Alright. This implies L square by b square is equal to 1 minus c square by s square. Alright. This implies L square by b square is equal to, taking LCM, s square minus c square. What is s square minus c square? We know that b square is equal to s square minus c square. So this will be going to be L square by b square is equal to b square by s square. This implies L square is equal to b to the power 4 by s square. Alright. This implies L is equal to plus minus b square by a. This signifies the presence of two lattice rectum. One is plus b square by a and the other is minus b square by a. Sorry, plus b square by a and minus b square by a. This length is plus b square by a, this length is this is on the negative side of y axis, so it is minus b square by a. So what is the total length of the lattice rectum? Therefore the total length of lattice rectum is twice L is equal to 2b square by a. Okay. So length of lattice rectum is 2b square by a. All right. Now let us note these points. What we have found. Number one, major axis. Let's start from the coordinates. Coordinates of origin. Coordinates of origin 0, 0. Coordinates of foci. Coordinates of foci plus minus C0, then coordinates of vertices plus minus A0. So this is minus A0 and this is plus A0. This vertex is plus A0. Okay. Thus plus minus A0 are the vertices. Next let's go to the length. Length of major axis twice A, length of minor axis twice b, length of lattice rectum two b square by a, then equation of major axis y equal to 0, equation of minor axis x equal to 0, equations of directrices, these two lines are the directrices and their equations are x plus minus a by e equal to 0. So this directrix is on the positive side. So x equal to a by e, that means x minus a by e equal to 0, and this directrix is x plus a by e is equal to 0. This length OZ1 is a by e, this length OZ2 is also a by e. So distance between the directrices is twice a by e. Distance between the vertices is the length of major axis, that means twice a. Distance between the foci is twice c. Remember these things. Okay. And what is c? Distance of one focus from the origin. What is the distance of the directrix from the nearest focus? Distance of a directrix from the nearest focus is, this length is a by e and this length is c. So a by e minus c. Distance of a vertex from the nearest directrix is a by e minus a. Okay, do you see here? Coordinates of a2, that means one vertex is a0, and equation of this is x equal to a by e, that means this length, this complete length OZ2 is a by e. This length OZ2 is a by e. This complete length is a by e, and this length this length from O to A2 is a. So the distance of a vertex from the nearest foci is, that means this length is a minus a by e. Okay, and what is the distance between distance of a vertex from the nearest focus? This length, this is a, this is c, so a minus c. Distance of a focus from the nearest vertex is a minus c. Remember these things, these are useful also. Okay, so let's write here distance between the directrices is twice a by e. Okay, then distance of a vertex from nearest focus is equal to a minus c. This distance is a minus c. OA2 is equal to a and OF1 is equal to c. So this distance F1A2 is a minus c. Okay, sorry, so this is F1 and this is F2. F2A2 is a minus c. Then distance of a directrix, distance of a vertex from nearest directrix is equal to a by e minus a. Okay, then distance of a focus from nearest directrix, these points will be very important from for questions. When we go for solving questions, there will be hints from these points, so we have to remember these points. Distance of a focus from nearest directrix, is equal to a by e minus ae. A by e minus ae means c. Okay, c. What is the value of c? Value of c is ae. All right. So these are the points you have to remember for solving questions. Fix this picture in your brain. This will help you solving problems. Now the question is, can you have an ellipse? Can you have an ellipse like this, whose major axis is y axis and minor axis is x axis? That means it is stretched along y axis and flattened along y axis. Sorry, x axis. Stretched along y axis and flattened along x axis. Can we have an ellipse like this? Of course, why not? We may have an ellipse like this. So what will be its equation? Okay, let's study this ellipse whose major axis is x axis. What is its equation? Its equation is x square by a square plus y square by b square is equal to 1, where b square is equal to a square minus c square is a positive quantity. B square must be a positive quantity. Okay. Okay. So we see that a square is greater than b square, because c square is also a positive quantity, non-negative quantity. On subtracting this non-negative quantity from a square, it becomes equal to b square. So a square is greater than b square. So when the major axis is along x axis, a square, that is x square by a square, what is in the denominator here is greater than the denominator that is in the denominator of y square. So denominator, what is in the denominator of x square is greater than the quantity in the denominator of y square, then the major axis lies along x axis. In this case, if a square greater than b square, then the major axis is along x axis. Okay. So when the major axis is along y axis, obviously that a square will go to y. So the equation will be like this: x square by b square plus y square by a square is equal to 1. This will be the equation of this ellipse. Here also a is greater than b, a greater than b, and in this equation also a greater than b. What is the difference? A is in the denominator of x, a square in the denominator of x square here, and a square is in the denominator of y square here. So just imagine if we write an equation like this: x square by 24 plus, or 25, say x square by 25 plus y square by 16 is equal to 1. Which type of ellipse is this? This type or this type? Okay. As x square has the greater denominator, so the major axis will be along x axis. So this is of this type, where the major axis is along x axis. Instead, if the equation becomes this: x square by 9 plus y square by 16 is equal to 1. X square by 9 plus y square by 16 is equal to 1, then it will be of this type, because y square has the greater denominator. So it will be stressed along y axis and the major axis will be y axis. Now for this ellipse, whose equation is x square by b square plus y square by a square is equal to 1, can we write down the informations? What is the coordinates of center? What happened here? X and y are interchanged with respect to a square and b square. Okay. So coordinates of center will be 0, 0. It neither depends on x, neither depends on y. X and y are equal. So coordinates of center will be 0, 0. Okay. What are the coordinates of vertices? Coordinates of vertices, for this coordinates of vertices are a0 and minus a0, and for this x and y will be interchanged. So the coordinates of vertices will be 0 plus minus a. Coordinates of vertices will be 0 plus minus a. Okay. Then what are the coordinates of foci? Okay. What is the coordinate of foci of this ellipse? Plus minus c0, and for this ellipse x and y will be interchanged and it will be 0 plus minus c. When the major axis becomes y axis, the coordinates of foci are 0 plus minus c. Foci always lies on the major axis. The line joining the foci is the major axis. So y axis is the major axis and foci will be on y axis, and the coordinates of foci will be 0 plus minus c. Now let's come to the length. Length will remain the same. What is the length of major axis? Length of major axis is twice a, length of minor axis is twice b, if the equation is of this form. Okay. Length of lattice rectum 2b square by a. Again, in case of equation there will be a change. What is the equation of major axis? Here the equation of major axis become x equal to 0. Equation of minor axis will be y equal to 0, and equation of directrices. What is the equation of directrices for this ellipse? X plus minus a by e, and for this ellipse it will be y plus minus a by e equal to 0. Okay. So these are the informations you have to remember. Okay. For this ellipse, major axis is the x axis, center is the origin. For this ellipse, major axis is the y axis and center is the origin. So a first example is, find the length of the axis, length of a lattice rectum, eccentricity, coordinates of foci and vertices, and the equation of directrices of the ellipse. First one, 9x square plus 16y square is equal to 144. Second one, 3x square plus 2y square is equal to 18. Okay, let's solve. First one first. So equation of the ellipse is 9x square plus 16y square is equal to 144. So what is the equation of ellipse? Either it is x square by s square plus y square by b square is equal to 1, or x square by b square plus y square by s square is equal to 1. So the right hand side should be 1. Let's divide with 144. On dividing, this becomes x square by 16 plus y square by 9 is equal to 1. Okay, now this is of the form x square by s square plus y square by b square is equal to 1. Okay, so what is about its major axis, x axis or y axis? You see, x square has the greater denominator, x square has the greater denominator, so its major axis will be along x axis. We have to write the informations according to this. Okay, comparing the equation with the standard equation, x square by s square plus y square by b square is equal to 1, s square is equal to 16, b square is equal to 9. This implies a is equal to 4 and b is equal to 3. Now we can find the eccentricity. We have b square is equal to s square minus c square. B square is equal to s square minus c square. Okay, where c is equal to AE, this implies b square is equal to s square minus s square square. This implies b square by s square is equal to 1 minus square. This implies square is equal to 1 minus b square by s square. So we use this formula to find eccentricity of an ellipse of this form, where the major axis is x axis, square is equal to 1 minus b square by s square. So by putting the value of a and b, we get square equal to 1 minus, what is b square? B square is 9. So 9 by 16. Okay, s square is 16. So this is equal to 16 minus 9 by 16 is equal to 5 by 16. This implies value of E is root 5 by 4. So eccentricity is under root 5 by 4, root over 5 by 4. Okay, thus we find eccentricity. Okay, then the length of axis, length of major axis is equal to twice a is equal to 2 into, what is a? A is 4, 2 into 4 is equal to 8 units. Length of minor axis is equal to twice b is equal to 2 into 3. What is b? B is 3. 2 into 3 is equal to 6 units. Okay, so length of axis, then length of lattice rectum. Length of lattice rectum is equal to 2b square by a is equal to 2 into, what is b square? 9, and what is a? A is 4. Okay, so this is 9 by 2 units. 9 by 2 units. Then eccentricity we have already found. Then coordinates of foci. coordinates of foci. Coordinates of foci is plus minus C0, plus minus C0. And what is C? C is AE. AE, what is the value of AE? Value of AE is root 5. Okay. Plus minus C is AE 0, plus minus A means 4, root 5 by 4, A is 4, E is root 5 by 4, comma 0, this is equal to plus minus root 5, 0. So coordinates of foci are plus minus root 5, 0. Then coordinates of vertices. We are solving question number 1. Coordinates of vertices. X-axis is major axis. Always remember that. Plus minus A0, that is plus minus 4, 0. Value of A is 4. Then equation of directrices. Equation of directrices, x plus minus A by E is equal to 0. This implies x plus minus, what is A? A is 4. What is E? Root 5 by 4 is equal to 0. This implies x plus minus 16 by root 5 is equal to 0. This implies root 5x plus minus 16 equal to 0. So these are the equations of directrices. Okay. Here not asked, but in some questions you may be asked about equations of axis. So equation of major axis, as the major axis is along x-axis. So equation of major axis, y equal to 0. Equation of minor axis, x equal to 0. Okay. Let's solve question number 2, the second one, in the same manner. So while solving these questions, first of all you have to decide which one is the major axis, x-axis or y-axis, and that can be found from the denominators of x square and y square. If the denominator of x square is greater, then x-axis is the major axis. All the coordinates or equations will be set according to that. And if the denominator of y square is greater, then y-axis is the major axis, and all the equations and coordinates will be set according to that. Okay, length does not alter. Number 2, equation of the ellipse is 3x square plus 2y square is equal to 18. This implies x square by 6 plus y square by 9 is equal to 1, dividing by 18. So which one has the greater denominator? Y square has the greater denominator. So which is the major axis? So y axis is the major axis. This must strike in your brain. So y axis is the major axis. We have to set the equations and the coordinates according to that. So comparing this, this equation with the standard equation, here we will write the equation as x square by b square plus y square by s square is equal to 1. Obviously a greater than b. Okay, we get b a is equal to 3 and b is equal to root 6. Okay, first of all let us find the eccentricity. We have b square is equal to s square minus c square. B square is equal to s square minus c square. And what is c? C is AE. So b square is equal to s square minus s square e square. So what is b square? Our b square is 6. What is s square? S square is you can take s square common. Okay. Next line we will put the values. So b square is 6, s square is 9. Okay. This implies 1 minus square is equal to 6 by 9. This implies square is equal to 1 minus 6 by 9 is equal to square is equal to 3 by 9, implies square is equal to 1 by 3. So E is equal to 1 by root 3. Value of E cannot be negative because this is the ratio of two distances. So eccentricity of the ellipse is 1 by root 3. Now we will find length of the axis. So first major axis, length of major axis is equal to twice A. What is the value of A? Value of A is 3. So is equal to 6 units. Length of minor axis is equal to twice B. What is the value of B? Root 6. So this is equal to 2 root 6 units. Then length of a lattice rectum. Length of a lattice rectum 2b square by A is equal to 2 into what is b square? B square is 6 divided by A. What is A? A is 3 is equal to 4 units. Okay, next eccentricity we have found already. Coordinates of foci. Coordinates. Okay, coordinates and equations are changed according to the equation of the ellipse. Coordinates of foci and vertices. Coordinates of foci. So major axis is the y-axis, so coordinates will be interchanged. Coordinates of foci are 0 plus minus c. Okay. What is the value of c? We can find it somewhere. C is equal to AE is equal to A is what? A is 3. Where is A? Where is A? A is 3. E is 1 by root 3. So value of C is root 3, and accordingly this will be 0 plus minus root 3. Then vertices. Coordinates of vertices, this is coordinate is equal to 0 plus minus A. 0 plus minus A. What is the value of A? Value of A is 3. So this is equal to 0 plus minus 3. Then equations of the directrices. Equation of the directrices, it will be y plus minus A by E is equal to 0. This implies y plus minus what is A? A is 3. What is E? E is 1 by root 3 is equal to 0. This implies y plus minus 3 root 3 is equal to 0. All right. Next question. So the second question, find the equation of the ellipse whose foci are plus minus 3 0 and eccentricity is 2 by 3. Also find the length of a lattice rectum. Okay, here you see both the foci lie on x-axis and the line joining the foci is the major axis, so major axis is the x-axis. Okay, we'll start from here. Since both the foci lie on x-axis, therefore x-axis is the major axis, let the equation of the ellipse be x square by a square plus y square by b square is equal to 1, where a is greater than b. Don't forget to write this, where a is greater than b. Now we are to find the equation of the ellipse. We have b square is equal to s square minus c square. This implies b square is equal to s square minus s square square. Okay. Okay. Before this, since foci are plus minus 3, 0, therefore what is the formula for foci? Plus minus c0, therefore c is equal to 3. We have b square is equal to s square minus c square. This implies b square is equal to, do you have a square? No, rather we have e. Okay, so s square minus s square square is equal to s square minus s square into 1 minus square need some simplification here. C is equal to 3 and C is AE is equal to 3 and AE is given to be 2 by 3. This implies A is equal to 9 by 2. A is equal to 9 by 2. Okay. Now we can find B square. So A is equal to 9 by 2, S square will be 81 by 4 minus C. What is C? C is equal to 3. All right. So B square is equal to 81 minus 12 by 4. This is equal to 9, 6, 69 by 4. Thus we find the values of A and B. Therefore, equation of the ellipse is x square by s square. What is s square? 81 by 4 plus y square by b square. What is b square? 69 by 4 is equal to 1. This implies 4x square by 81 plus 4y square by 69 is equal to 1. Now we are also to find the length of a lattice rectum. Length of a lattice rectum is equal to 2b square by a is equal to 2 into what is b square? B square is 69 by 4. What is a? A is 9 by 2 is equal to 69 by 2 divided by 9 by 2 is equal to 69 by 9 units. So, one mistake is there. C square, C is 3, C square is 9. So, this is 36. So, 81 minus 36 will be 45. So, b square is equal to 45 by 4. Equation of the ellipse will be like this, 45 by 4, this will be 845. And length of a lattice rectangle 2b square by 4, that is 45 by 4. So, 45 by 2 divided by 9 by 2, this is equal to 45 by 9 is equal to 5 units. And equation of the ellipse can be simplified further. Okay, leave it here. So, these are the answer. Okay. Next question. Find the equation of the ellipse whose axes are along the coordinate axis and which passes through the points 2, 4 and 3, 2. Here it is said that the axes are along the coordinate axis, but which axis is major axis is not stated here. Okay. So, we will start like this. Let the equation of the ellipse be x square by s square plus y square by b square is equal to 1. But don't write here a greater than b, because you don't know which axis is the major axis. Okay. So, be careful of this mistake. Don't write here a greater than b, because we don't know which axis is the major axis. We will just write x square by s square plus y square by b square is equal to 1, where either a may be greater than b or b may be greater than a. It will be decided later on. Okay. Since the ellipse passes through the points 2, 4 and 3, 2. Therefore, it will be satisfied by these points 4 by s square from the first point plus 16 by b square is equal to 1. Mark this by 1, equation number 1, and from the second point 9 by s square plus 4 by b square is equal to 1, mark this by 2. We have to solve this equation to find the values of s square and b square. Okay. So, by elimination method, 1 minus 2 into 4 implies, we multiply the equation number 2 by 4. So, it will be 4 by s square minus 36 by s square is equal to 1 minus 4. So, 16 by b square will be cancelled. This implies minus 32 by s square is equal to minus 3. This implies s square is equal to 32 by 3. Okay. So, value of s square is 32 by 3. From this, we will find the value of b square by substituting the value of s square in any one of these equations, say in equation 1. So, 1 implies 4 by 32 by 3 plus 16 by b square is equal to 1. Okay, just by putting the value of a here. So, this will be 432, this will be 8 and 3 will go up, plus 16 by b square is equal to 1. This implies 16 by b square is equal to 1 minus 8 by 3, implies 16 by b square is equal to what will be this? 1 minus 3 by 8. So, what will be this? 5 by 8. Okay, this implies b square will be equal to 16 into 8 divided by 5. This is equal to 144 by 5. Am I correct? $128 by 5. What is wrong here? Oh yeah, this will be 128. So 128 by 5. Now we can write down the equation of the ellipse. Therefore, equation of the ellipse is x square by s square. S square. What is s square? 32 by 3. So x square by 32 by 3 plus y square by b square. What is b square? 128 by 5 is equal to 1. This implies 3x square by 32 plus 5y square by 128 is equal to 1, and this is the answer. Okay. Let's move to the next question. Okay, next question is, find the equation of the ellipse x square by s square plus y square by b square is equal to 1, where a greater than b, if the length of a lattice rectangle be same as the length of a minor axis. Here it is said that a is greater than b, so obviously major axis is the x-axis. Okay. Solution. According to question, length of a lattice rectangle, that is 2b square by a, is equal to length of a minor axis, that is b. Okay. So this implies a is equal to twice b. Okay. From this we are to find the equation of the ellipse. Okay, there is a correction. Find the eccentricity of the ellipse x square by s square plus y square by b square is equal to 1, a greater than b, if the length of a lattice rectangle be same as the length of a minor axis. So from here we are to find the eccentricity of the ellipse. This implies s square is equal to 4b square. This implies s square is equal to 4. What is b square? B square is equal to s square minus c square. All right. And what is c? C is AE. So c square will be s square into e square. Taking s square common, this implies s square is equal to 4s square into 1 minus e square. This implies 1 is equal to 4 into 1 minus e square. This implies 1 minus e square is equal to 1 by 4. This implies e square is equal to 1 minus 1 by 4. This implies e square is equal to 3 by 4. This implies e is equal to root 3 by 2. Okay. So the question is, find the eccentricity of the ellipse whose lattice rectangle is 4 units. Lattice rectangle is 4 units, and the distance of a vertex from the nearest focus is 1.5 units. The major and minor axis being along the coordinate axis. Okay. So the equation of the ellipse may be either x square by s square plus y square by b square is equal to 1, or x square by b square plus y square by a square is equal to 1. This is not going to affect our answer, okay, because our answer is neither related to coordinate nor related to equation. So without loss of generosity, we can write, let the equation of the ellipse be, we have to write some equation, otherwise we cannot write down the formula, x square by s square plus y square by b square is equal to 1, where we take a is greater than b, that means x axis is the major axis. Therefore, by question, what is in the question? Lattice rectum is 4 units. So what is lattice rectum? 2b square by a is equal to 4. And the distance of a vertex, do you remember? This is vertex, this is focus, coordinate of vertex a0, coordinates of focus ae0 or c0. So the distance of a vertex from the nearest focus is a minus c. I have given you a note already, and a minus c is equal to how much? 1.5. From this we are to find the eccentricity of the ellipse. So this will imply a minus ae is equal to 3 by 2, okay, or a minus c is equal to 3 by 2. This implies, okay, leave it here. This will imply 2b square is equal to 4a square. And what is b square? 2 into a square minus c square is equal to 4a square. This will imply a square minus c square is equal to 2a square. This will imply a square minus a square is equal to 2 a square, okay. 2b square is equal to 4a square. Length of a lattice rectum, 2b square by a is equal to 4, all right. 1 minus square is equal to 2, all right. Here we go. So one part gives us 2b square by a is equal to 4. On simplifying, 2b square is equal to 4a. 2 into b square means a square minus c square is equal to 4a. So a square minus c square is equal to twice a. So a square minus a square is equal to twice a, because c is equal to ae. Taking a square common, a square into 1 minus square is equal to twice a. This implies a into a plus 1 minus square can be written as a cancelled. 1 minus square can be written as 1 plus e into 1 minus e is equal to 2. We leave it here. Then from here, a minus c is equal to 1.5, a minus c is equal to 3 by 2, c is ae. So a into 1 minus e is equal to 3 by 2. We will use this value here. This implies 1 plus e into a into 1 minus e is equal to 2. A into 1 minus e is 3 by 2. So this will imply 1 plus e is equal into 3 by 2 is equal to 2. This implies 1 plus e is equal to 4 by 3. So e is equal to 4 by 3 minus 1, that is 1 by 3. Thus we find the eccentricity as 1 by 3. Mark it by 1, and here you write from 1. All right. Thus we find the eccentricity of the ellipse. Next question is, find the equation of the ellipse whose vertices are plus minus 13, 0 and foci are plus minus 5, 0. Here both the foci lie on x-axis, so x-axis is the major axis. Solution: since both foci lie on x-axis. So, x-axis is the major axis. What is major axis? The line joining the foci is the major axis. So, x-axis is the major axis. Let the equation of the ellipse be x square by a square plus y square by b square is equal to 1, where a is greater than b. Therefore, by equation a is equal a0 plus minus a0 is equal to plus minus 13 0. Therefore, a is equal to 13 and plus minus C0 is equal to plus minus 50. This implies C is equal to 5. We have B square is equal to S square minus C square is equal to S square means 13 square, that means 169, minus C square means 25 is equal to 144. Therefore, equation of the ellipse is x square by s square. S square means what? 169 plus y square by b square. B square means 144 is equal to 1. Thus, we find the equation of the ellipse. So, this is the homework time from your NCERT book, page 154, example 12 and exercise 11.3, all problems. From class book, page 267, example 5, exercise 14.2, question number 1, under question number 1, Roman 3 and Roman 4. Then question number 2, 3, 4, 5, 6, 7, 9 and 10. Okay, thank you. In next video, we will learn about hyperbola.